Hello everyone. Once again welcome you all in the online lectures, and from last lectures we are talking about the total synthesis of this thienamycin. In previous lecture we already discussed the route for the synthesis of this thienamycin. Merck and his group develop another route for the synthesis of this thienamycin. Instead of taking L-aspartic acid, he uses, that is 1,3-acetone dicarboxylate. So this 1,3-acetone dicarboxylate, so this is 1,3-acetone dicarboxylate, CO2 18. So this molecule will be treated with this benzyl amine in presence of toluene, and this molecule was filtered on a molecular sieves to get a pure enamine, and this enamine will be looks like this. Here is CO2 CO2 and here is reduced formation of a NHBN. Right? So this enamine is formed. Then further this enamine will be treated with this ketene gas in presence of toluene, that is PHCH3. It gives formation of ketoenamine, and this ketoenamine will be looks like this. Here is CO2 here is CO2 and here is it gives formation of a ketoenamine like this, right? So it gives formation of a hydrogen bond at this position. Then in the further step, this compound will be reduced by using a sodium cyanoborohydride in presence of solvent, that is ACOH, acetic acid. Then it gives formation of a intermediate, and the structure of this intermediate will be looks like this. So here is, so this is hydrogen, this is OH, this is methyl group. That means this group will be reduced. Here is CO2 here is again CO2 and here is this NHBN group, and this is the hydrogen, right? So this is called as a intermediate. So this intermediate will be obtained in the, so this is the intermediate, and this intermediate will be obtained in the racemic form. Then further this compound will be, so this will be obtained in the racemic form, and this compound when we undergoes lactonization in presence of concentrated HCl, so it undergoes a lactonization, and after lactonization what it gives? It gives a compound like this. Here is the oxygen in this way. So this is a carbonyl group, then it is a methyl substitution, and here is the CO2, here is the CO2H group, and this is the NHBN group, and this is called as a lactone. Then this lactone, there is deprotection will be done by using this palladium hydroxide on carbon at 40 psi hydrogen. So this is catalytic hydrogenation, and after that catalytic hydrogenation in presence of acetic acid, what it gives? It will be deprotect this amine group, and it gives formation of a compound like this, CO2H. Here is the oxygen, here is methyl group, here is carbon group, and here is this is NHSCl. Then in the further step, the lactone ring will be open, and after opening it will be undergoes a esterification by using this benzyl hydroxide in presence of acetic acid with catalytic amount, and if we heat this compound for 70 degree and for 16 hours, then it gives a opening of the ring, and after opening of the ring it gives a compound like this. Here is NH, here is NH2SCl, here is CO2H, and here is this CO2BN, and this is the hydrogen below the plane, this is the hydrogen above the plane, and here is, if we see, so this is methyl group and this is the hydroxyl group, right? If we see in thienamycin, so this hydroxyl group is above the plane. So in thienamycin, this hydroxyl group is above the plane, but in this synthesis, so this hydroxyl group is below the plane, right? So it means in further step, we have to again epimerize this C8 center, and this epimerization will be takes place in the further step. So that will be discussed later on. Now in this step, we get a such type of compound. Then in the further step, so there is cyclization of the ring will be done by using this DCC, that is 1,3 dicyclo. So 1,3 dicyclohexyl carbondiamide in presence of, that is, triethylamine, as well as a solvent, that is acetonitrile CH3CN, and for 60 degrees Celsius. So it undergoes cyclization, and the cyclic product will be like this. So it contains this NH group. So this is carbonyl group. Then this is CO2BN group. So this is the hydrogen. And if we see, this is methyl group, and this is the hydrogen, right? So we get such type of intermediate, and this intermediate will be obtained in the crystalline form, and it is called as a beta lactam. Then in the further step, we are deprotecting this nitrogen group by using a silyl protection. That means by using a tertiary butyl dimethyl silyl chloride, and using a base, that is triethylamine, and solvent, that is DMF. And in the further step, we can treat this compound with this PDC. So that means catalytic reduction by using hydrogen at 40 psi, and in presence of solvent, that is methanol. So what it gives? It gives a compound like this. Here is this NR group. That means R group is nothing but tertiary butyl dimethyl silyl, and this is the carbon group, which is same again here. Then here is this hydrogen above the plane, and here is it again gives protection of this alcohol. Here is this methyl group, and here is we can see CH2, then here is CO2BN, right? So this CO2BN group will be hydrolyzed, and it gives formation of a CO2H. That means it gives formation of a such type of compound. Then in the further step, we can treat this compound with 1,1-carbonyl diimidazole. So this 1,1-carbonyl diimidazole, that is IME2CO, in presence of solvent, that is CH2Cl2 chloro. So this CH2Cl2, so that is dichloromethane, and then it gives formation of a compound, and that compound will having a imidazolyl group at the carbonyl position, and we get a compound like this. So this is NR, here is carbonyl group, then here is the hydrogen above the plane. So this is OR group, this is methyl group, this is the hydrogen, and then CH2, then C double bond O, and here is it introduces this imidazolyl group at this position, right? So we get a such type of compound. Then in the further step, this compound will be treated with this Meldrum's acid, and the structure of this Meldrum's acid will be like this. So this is a Meldrum's acid, and in presence of 4-DMAP, then it gives formation of another intermediate, and that intermediate containing this Meldrum's acid as a functionalities. So here is this NR protection. So this is carbonyl group, then here is the OR protection group, this is methyl, this is hydrogen, and then it will be introduce this Meldrum's acid group at this position, and it gives a compound like this in this way, right? So here is the oxygen. So this is cyclic system, and it contains this carbonyl group, and this is again a carbonyl group. So it gives formation of a such type of intermediate. In further step, we can treat this compound with, that is para nitrobenzyl hydroxide in presence of acetonitrile CH3CN, and if we heat this compound, we get another type of intermediate, and that's intermediate containing such type of functionalities. So here is a carbon OR group, this is methyl, this is hydrogen above the plane, this is hydrogen below the plane, and here is it gives a carbonyl group, and then it having such type of functionalities. So CH3, here is this carbonyl group, and here the OH group, and this is OBN, right? Then in further step, so this hydrogen will be shifted here, and then this bond will be again shift here. It will be convert into this, and it gives formation of a, that is another intermediate. That means there is evolution of carbon dioxide, also evolution of this acetone CH3, COCH3, and we get a intermediate like this. So this intermediate contain this NR group. This is carbonyl. Then here is the hydrogen. So this is OR protection. Then here is methyl group, and this is hydrogen below the plane, and here it gives a C double bond O CH2. Then here is OBN group, right? So it gives a such type of intermediate. Then in the further step, so this compound will be purified by recrystallization in presence of isopropanol as a solvent. Then if we see, here is the hydroxyl group which is below the plane, and in thionylamine we have to convert this hydroxyl group into the above the plane, and for that we are doing a Mitsunobu reaction, and due to that Mitsunobu reaction there is inversion in the configuration at the C8 center, and then this inversion can be done by using the reagent, that is Mitsunobu reagent. Firstly, we can deprotect this OR group by using the HCl in presence of methanol. Then there is deprotection, and then in the second step we can treat this compound with this triphenyl phosphine, and then DIAD, that is diisopropyl azote carboxylate. Then in presence of this HCO2H, that is formic acid, and then we can use a solvent, that is THF at 25 degrees Celsius. And then in further step, again we can treat this compound with HCl in presence of methanol at 25 degrees Celsius, and then there is inversion in the configuration will be takes place, and the inversion will be like this. So here is NH, so this is carbonyl group, and here we can see, so this hydrogen which is below the plane, it becomes above the plane, and here is the methyl substitution, here is hydrogen, here is the hydrogen, and here is we can see that this is C double bond O O BN, right? So this intermediate will be obtained after the Mitsunobu reaction, and after that we can further treat this compound with various reagent, and so that means initially we have to, after that it gives a O CO2 PNB here. Here is CO2 PNB, and in the next step we can do insertion of this azide group at this position, then formation of the carbene group, then insertion of this NH into this carbene group, then it gives formation of a 5-member ring here. Then in the further step we can introduce this cysteine group into this molecule, and then it gives formation of thionylamine. That means the next route will be similar as like in the previous route which can use for the synthesis, right? So here we can see that this OH group is, that means converted from below to above the plane by using this Mitsunobu reaction. Merck and his group also did the epimerization at the C8 center by using this intermediate, right? So this is the intermediate, and from that intermediate he can convert. So this is the OH group. Now here it is below, above, it can be converted it into below, and then in the further step the similar reactions are same. So we can see how they can prepare the epimerization at this center by using this Mitsunobu reaction, and the remaining routes are the same here. If we see, this intermediate will be looks like this. Here is OH, here is this methyl group CO2 80, there is NHBN, and here is we can see that, so this is CO2 18, right? So this molecule will be similar in this way. So that means we are doing the epimerization at this center, and after that the epimerization which is done in the intermediate number 37 by using Mitsunobu reaction, we are doing the Mitsunobu reaction at this stage, and then we can convert this epimerization at this C8 center. Initially it can be treated with this HCl in presence of CH2Cl2, that is at 25 degrees Celsius. Then what happen? There is lactonization will be takes place, and after lactonization we get a molecule like this. Here is C double bond O, then here is this NHBN, here is this CO2 and this is the methyl group, right? So in the first step the lactonization will be done, and then after that it will be treated with this NaHCO3, and then in presence of water, then this lactone ring will be open, and after opening this lactone ring, what we get? We get a molecule like this. So here is CO2OH, here is again CO2OH here, then this is a methyl group, this is CO2 and here is the NHBN. Then in the next step, so this molecule will be treated with this triphenyl phosphine and diethyl azo dicarbonamide, that is Mitsunobu reaction, and then there is inversion will be takes place, and after that we get a molecule like this. So it containing oxygen, here is the carbonyl group, and here is this NHBN, here is CO2 and then this methyl group will be again come to the front side, right? So that means there is inversion at the C8 center will be takes place by using this Mitsunobu reaction, and then in further step we can convert this molecule into this intermediate, and after that this intermediate will be can be converted into this, we can say, thienamycin in the various stages that will be discussed in the previous lecture. Here we can see the mechanism for the inversion at this center. So what is the mechanism? If you see the mechanism, so this is the hydrogen, and if you see this dead group, that is diethyl azo carbonamide CO2 then NCO2 So what happened? This triphenyl phosphine containing lone pair will be attack on this nitrogen, and then it will be abstract this and it gives formation of a compound like this, right? So what we get here, here is C double bond O CH2, here is, so this group is NH2BN above the plane, so here is this NH2BN, and we get here the NH2BN, then here is CO2 here is OH, and this is the methyl group, right? So here it gives formation of a O minus. Then in the further step, there is shifting of the proton will be takes place. Here is OH, C double bond O, then here is NHBN, here is CO2 and here is it gives formation of a O minus, and this is the methyl group. Then in further step, this O minus will be attack on this nitrogen NCO2 here is PPH3 plus, and here is CO2 here is CO2 So this O minus will be attack on this triphenyl phosphine, and it will be remove this group here, and what we get here, then we get a molecule like this CO2 CH2, then here is CH2, So this is NHBN CO2 ET. Then here is, this is a methyl group. Then OH, and this is a triphenyl phosphine group. Here is this OPPH3 plus. Here is OPPH3 plus. This is methyl group, and this is the hydrogen, and this is O minus. This is OH. Then in further step, this O minus will be shifted here. It will be abstract this proton, so this hydrogen, and then it will be shifted here, and this will be attack on this group, and it will be remove this triphenyl phosphine, and after that it will be remove this minus triphenyl phosphine group, and it gives formation of a cyclic lactone, and that cyclic lactone will be like this. Here is the carbon-carbon double bond. Here is oxygen, and here is this methyl group, and here is this NHBN. So this is CO2 ET. And if we heat this compound in presence of concentrated HCl, it gives formation of a, so this type of intermediate, right? And then, so this is the mechanism for the inversion in the configuration at the C8 center by using this Mitsunobu reaction, right? And then in further step, the all other steps will be similar as will be discussed in previous lectures. So friends, with this we can stop here. The remaining part will be discussed in next lecture. Thank you.